Okay, so in the previous class, we had actually covered this whole set of slides, but I just want to make some of this more clear to you guys. So that's why I'll be recording this whole session. So basically, just a recap of things, we studied three different types of relationship. That was one-to-one relationship, which would basically have two primary keys, and then a one-to-many relationship, which will have a foreign key present in the table, which holds the many relationships, and then a many-to-many, which introduces a bridge table holding the primary composite key. Now, in today's class, what we had basically done was we had a one-to-one relationship between entities or tables, and we had also mapped one of the one-to-many relationship between entities and tables, right? So this was the scenario that I had given to you guys. So let's zoom in a bit more into it. So since you guys had asked for a banking enterprise architecture database management system, this is a requirements document that I had built out for Bank of X Inc. So it has recently started a MySQL for developing its database management system, and they're trying to set up customer information. So as you can see from this, your first table is going to be the customer table. So let me just highlight that. So that's going to be your first table. In other words, your entity. So you're going to make note of the following information. So you have a customer table, and the next set of information that you have to extract are the attributes for this customer table. So we will have the customer's first and last name, the address, telephone number, and then their unique ID. So let's start off with the customer ID, which is basically the primary key of this table. So I'm going to underline this. And then the next set is going to be the first name of the customer, the last name of the customer, the address, and then their telephone number. Okay. So these are the various information that they've asked in the customer table. So far we have addressed this section of our requirements document. The next part is that each customer will have one biometric detail associated with them. So the upper management wants the customer details and the biometrics to be stored separately for security purposes. So what they're basically asking in this particular requirements section of the document is that they want a different table separately for biometrics, right? So we create a separate table for biometrics, and let's say this particular table must have its own unique identifier. So I'm going to say bio ID here. Okay, so that's going to become the primary key here. Okay, and let's say they have information such as the okay, this is not going to be aligned anymore. This is going to have information such as customer sorry, biometric eye detail, and then let's say a fingerprint associated with it. Okay, these are going to be attributes, other attributes in that table. Now we need to connect every customer ID to the biometrics table. So every customer will have a unique bio ID, and every biometric table will have a unique customer associated with it. So let's say I'm the customer. I just have one biometric associated to myself, and every biometric is uniquely associated to me. So it is a one-to-one relationship here. But in order to connect this, we need a foreign key, right? So the foreign key in this will be the primary key of this table. Okay. So yeah, let's underline this. So basically, this is how our one-to-one entity relationship diagram is going to look like. Let me stop the share. Now, we did the first section of that particular, requirements document, but now what we need to do is we need to start drawing the entire diagram, right? So let's start drawing the diagram. Okay, so let me just share my screen here. What I did was I went to this app called as draw.io, and I'm going to click on decide later here. Okay. So the first thing I'm going to go to this entity relationship area, and I'm going to start with a table. So as you remember, the first table that we had created was a customer table. The customer table had a customer unique ID, and it also had attributes such as first name, and then it had attributes like last name, and then it also had the address of the customer, and it also had the telephone number of the customer, and so on. The next table that they had asked for was a biometric table, right? So we're going to keep this as a biometric table, and it's going to have a unique ID called as bio ID, because we need to uniquely identify this table, right? So every time you create a new table, always remember there should be a primary key associated with it. Okay. So then now we have some metrics, biometrics data here. This is one biometric data. The other one would be, let's say, a fingerprint data that we have on them. But now we need to draw out a relationship between the customer and the biometric. And this is where I'll be covering in the next class on, the cardinalities. But for now, we have a one-to-one relationship. So every customer ID is uniquely associated to one bio ID, and every bio ID is uniquely associated with the customer ID. Okay. So it will be a one-to-one relationship. So this is how we do it. Okay, we mapped it right here. Okay, at the minimum, so this line that you see here, at the minimum, you have one customer ID, and at the maximum you can have is one customer ID. Similarly here, at the minimum, you can have one bio ID, and at the maximum, every customer ID can have one bio ID, okay? Now we need to connect this still, right? Like we need something that is basically, let's say we have biometric and then fingerprint. We still don't know whose customer ID, when we access this particular database, we still don't know which customer ID it belongs to, right? So for that, we need another attribute in that table called as customer ID. So there we have our first, mapping done. Now what we're going to do is we're going to go back to our requirements document. So let me share that screen. Okay, so we have finished this part of the requirements document. Okay, I'm going to remove this out because we have finished this. The next part is that each customer can have multiple accounts. Okay, so we had, let me actually go back to that. We have the customer ID, a customer table, so we'll keep that. So every customer will have multiple accounts, and however, each account will have only one customer associated with it at max. Now, accounts must have unique ID, balance, account status, type, created ad, deleted ad, and the currency. So the next table that we'll have to start creating is the account table, right? Now, the first thing that you'll think of is to create a unique ID here. So let's go ahead and create a unique ID for this particular table. That's the primary key. Now they've asked us for, details such as balance. I'm going to remove out the underlined. Yeah, so they have asked us for the balance, this account status, and they've asked us for the type of account, then created at, and deleted at, and the currency type. Okay. So these are the various attributes that they've asked us. Now, however, we don't know how to connect this and this yet, right? We let's say we access this particular database or data table. We have the account ID, we have balance, we have status, type, created ad, deleted ad, and the currency, but we don't know which customer ID this belongs to. So what we do is we include a foreign key in this, right? So the foreign key is basically our customer ID. Now, if you look at the associations, however, each account will have only one customer associated with it. So every account ID will just have one customer ID, okay, unique customer ID with it. But however, every customer ID can have multiple account IDs. So what do we do? What do we have here? We have a one-to-many association, right? So let's map out that association on the ER diagram. I will share the diagram. Okay, so we have this right here. Oops, let me stop that share. I think we had a different one. Okay, so I'm going to share this screen right here. Okay. So what we had here was basically our account table, which was the newly added table. So I'm going to add that right here. We need another table. And this table is going to give me all the account details. Okay. So we have account here. And now the account details had a primary key called as account ID. Okay. And the other details that it had was basically a balance, and then it had the status, then it had the type, then it had created at, deleted at, currency, and so let me add those. And finally, the foreign key, we have to mention that here, foreign key is basically going to become the one that holds the many associations. So for now, I'll just keep this empty. Also, another small correction here, you have to mention that this is a foreign key, okay? Don't forget to mention that this customer ID is the foreign key. All right. So here, before mentioning the customer, that this is a foreign key, what we do is we have to draw out this mapping, this relationship mapping, because I'll tell you why in a bit. So basically, it will be every customer has many accounts, right? So the many association comes here. At minimum, every customer will have just one association or many associations. Okay, so let me just draw that out. So this will be our association here. It will be a many. And at the maximum, every account is going to have a one relationship only. Okay. I'm just trying to figure this out, the relationship mapping. Okay. So every customer will basically have at the minimum one and at the maximum many accounts. Okay. So the initial thing that you draw is a one and then a many relationship here. Okay. So this is called as a cardinality. Okay. This whole thing right here is called as your cardinality. So it is mapped out to be like, it's basically going to look like this. Let me go back here and add a small table here. So it's going to look like the cardinality, the minimum cardinality is going to be one, and the maximum cardinality is going to be many. Okay. So that's why it's a one and a many, okay, which we have already covered in the previous few classes. Now here, every account is only associated at the minimum one customer ID it has to have, and at the maximum, it can only have one customer ID. So think of it this way. We have a savings account, okay? This savings account can only have one customer ID associated with it, right? But now think of it the other way. I have a customer ID, but I can have multiple accounts IDs. So I can have a savings account ID. I can also have a checkings account ID. So that's the way you can remember this. All right. Now, the next thing that you can also draw is basically, we go back to the requirements document. So let me just go back to the requirements document right now. So you see my requirements document here, right? So let's see what we missed. Have we missed anything? Each customer can have multiple accounts. However, each customer account will have only one customer associated with that. So we drew out that particular mapping there. The next set of stuff that they've asked is basically each customer can have multiple loan applications. However, each loan application can have only one customer associated with it. Loans will have a unique ID, loan amount, date issued, created at, and deleted at. Okay. So the next table that we'll create is a loan table, right? And now we have a loan ID here because, of course, like this one has to have a primary key in its table. Okay, so let's underline this. Now, the remaining information that you guys will have is on the loan amount. And then we have the date issued, that the loan date was issued. And then created at, when this was created at, if this loan was deleted. Okay, so these are the various information. Now, one thing that we're missing is the attribute that basically connects this table to the customer table, right? From this question that you see. So each customer can have multiple loan applications. However, each loan application can have only one customer associated with it. So this relationship is missing. So what is the foreign key that you guys have to introduce in here? It has to be the customer ID, all right? So let me just put that in here. So that becomes your foreign key here, okay? Let me just underline this as well. Okay, so let's go back to the just a second. Right. So let's go back here and then draw out the loan table now, okay? So we now need a loan table. So I'm going to introduce the loan table in here. All right. So we have a loan table and then we have loan ID as the primary key. The amount, loan amount was one of the attributes. Then we also have, what other attributes have I mentioned here? Loan amount, and then we had date issued. Then we had created at, and then we had deleted at. Then we also had our foreign key, which was basically the customer ID. Okay. Now, what are they saying? They're saying that every customer will have multiple loan applications. So it will be a one to a many relationship again, right? So it'll be the same relationship, but this time it's going to go from customer to our loan, right? So that's how the relationship is going to look like. So if you can see here, every customer will have one minimum cardinality one and maximum cardinality as many. Okay, so that's what we're going to write here. Okay, and then similarly, every loan will have at the minimum, loan ID will have at the minimum one customer associated to it, and at the maximum, just one customer ID. Okay. Because think of it this way, right? I apply for a loan, they give me a unique loan ID for that particular loan, like let's say an auto loan, okay? There will be only one and only one customer at the max associated with that loan ID, okay? That is what this particular thing says, requirements document says. So basically, we have finished drawing the, the ERDs, ER modeling diagrams so far for this particular part of the requirements document. So this is how it's going to look like. Okay. So this is how it's going to look like. Okay. So let me take a screenshot of it so that we are here so far. Okay, that's done. Now the next part is going to basically, we're going to move on to the next part of it, okay? Which is basically this part of the requirements document. Now, Bank of X Inc. wants to further grow the database and start keeping track of the transactions made by each of the accounts. Every account will have many transactions. However, every transaction is made by at least and at most by one account only, okay? Now, what are we thinking of here, right? So we think of the associations to the already existing database table. So where should the relationship be mapped to? Look at the tables here, okay? The first thing you'll think of is the accounts table that it can be mapped to. And what we are creating newly is the transactions table. So let's go ahead and create the transactions table. Before that, let's map out how the transaction table is going to look like. Okay? So this will be your transaction table. And then we will have all the different attributes in it. So a transaction ID, and then we have the type of transaction, the date issued, amount transacted, amount medium, transaction medium, and then deleted at. Okay. Now your primary key is going to be this transaction key, but we also want to basically connect this to the accounts table, right? So we already had this account table here. So I'm going to bring this in here. Okay. So what is the, primary foreign key that that is basically used here, right? So that is your account ID, right? Because you are connecting it to the accounts table. So the primary key of this table becomes the foreign key for this table, okay? Because this is the table which holds the many relationship, and I'll show it to you guys in a couple of minutes. So let's go ahead and create the ER diagram for this particular table. So you have your transactions here, and then a transaction ID here. And then you have all these other attributes, like this can be anything, guys. You can name this as anything. It depends on you guys, what you're comfortable with, but it doesn't have to have a, standard format that you need to follow for it. So type, date issued, amount transacted. Usually, like the requirements document will give you, idea as to what are the attributes, but the heading, the column names can be according to you. Like you can name it however, like you can even put this as transacted medium, or you can put it as transact medium. So it doesn't matter how your the naming conventions look like. Okay. This is deleted at, and then of course we have a foreign key, right? So the foreign key is the account ID, because but yeah, this one has to be similar. Whatever naming convention you're putting in here has to be similar to whatever it is in the other account, so account ID, okay? So this becomes our foreign key. Now, why is the foreign key located? Just give me a minute. Yeah. So why is the foreign key in this particular, table, and why did we not include a foreign key here? Right? So let me make this concept very clear to you guys. This particular table will have the foreign key as, because this has the many relationship, right? So with which table does it have the many relationship from? The many relationship is coming from this table, right? It's coming from this table. So the primary key of this particular table that, it's associated to will become the foreign key in this table. So this is our foreign key here. But now think of it this way. It'll have the same relationship, right? But the account table is now giving a many relationship to the transactions table, right? So let's just make this clear. Yeah. So the transactions table is now having is holding the many relationship, but the many relationship is coming from the accounts table. So the primary key of the account table becomes the foreign key for the table that it holds the many associations from. So look at this particular, requirements document, right? Now it says that every account will have many transactions, right? So now every account table will have many transactions associated. So every account ID will have multiple transaction IDs. So therefore, it's a one-to-many relationship, right? Because every transaction is made by at least and at most one account only. So this one holds the one relationship, and this one holds the many relationship, right? The one with the table with the many relationship will basically hold the primary key of the other table that it's associated to, okay, as the foreign key. Okay, it's a pretty a little bit tricky in this, in this concept specifically is a little bit tricky. So, you have to pay attention to this part a little bit when you're drawing out your entity relationship models. Now, the cardinality, this is the relationship, right? It's a one-to-many relationship. But the cardinality itself is basically, let's draw it out here. The cardinality will be, the minimum cardinality that this holds is 1, and the maximum it holds is 1, okay? Similarly, the minimum cardinality, this particular part of the relationship holds is 1, and maximum is many, okay? So we're telling to the database that at the minimum, every account ID should have at least one transaction ID, okay? Not 0. And at the maximum, it can have many number of transactions, okay? Similarly, the transaction table to the account table, I'm saying that at the minimum, it should have at least one account ID associated to it. And at the maximum, it can have only one account associated to it, okay? The reason why we bring in these cardinalities is because sometimes like relationships can also be 0, right? Remember we went over this concept in class. It can also have minimum of 0 and a maximum of 1, okay? So that's one of the reasons why, in order to like make it more clear to the end users or the people reading these diagrams, we're giving these particular, cardinalities here, okay? But the relationship itself is going to be a one-to-many relationship, okay? So relationships and cardinalities are completely different concepts. And I want to make that clear like a couple of more times. I'll be reiterating it to you guys so that you guys don't get confused. Now we finished this part of the requirements document. I think we went over all of this. Yeah, we went over this. The last part of it is going to be this third requirements part of the document, okay? So here, what they say is basically, they're saying Bank of X now started 3 more branches, okay? And multiple branches can give out many loans, but each loan given out is associated to only one branch, okay? So now the new thing that we'll be bringing in is the branch table, right? So as you can see from the table itself, from the requirements document itself. Now, which association, to which table is this association mapped to, right? So you need to look for any other keywords in here. So basically it's, as you can see here, loan is one of the tables that it's associated with. So you quickly look for in your database if you have the loan table. And we did have that loan table right here, right? We created that earlier. So we're going to go back and map it to the loan table. And now each branch entity, what are the different attributes that it will hold? The first thing will be a branch ID, because of course that is our unique key. And the next thing it's going to have is all these other attributes that are listed. That's basically our branch name, and then the branch location, and then created at and deleted at. Okay. And then we also have the foreign key that has to make the relationship between branch and loan. But where does the foreign key come now, right? It comes to which one? The one which has the many relationship, right? So basically now it has started 3 or more branches, and multiple branches can give out many loans, right? But each loan will be given out to only one branch, right? So which one has the many relationship? If you think of it for a second, it says that multiple branches can give out many loans, right? So the one with many loans will basically have the foreign key, right? So your foreign key comes in here, branch ID. Okay. Now, but each loan is given out is associated to only one branch. Do you see this? So now each branch, we already came up with the attributes. Now what we do is we draw the ER diagram here. Okay, ER modeling diagram. So let's bring out the other table, which is basically our branch table. Let me draw that out for you guys. Okay. And then we're going to have these various attributes there, which is basically our branch ID. And then the branch name. And then we have branch location, created at and deleted at. Location, created at, and deleted at. Okay. Now, as you saw, it's basically associated with the loan table, right? So what they're saying is multiple branches can give out many loans, but each loan given out is associated to only one branch. Okay. So where does the one relationship come? Basically comes here, right? From loan to branch, it's a one relationship, and from branch to loan, it's a many relationship, right? So this is how the association is going to look like. Okay. Now, where does the foreign key come under, right? The one with the many relationship. Now, this one is holding the many relationship, so we put in the foreign key here, okay? So the primary key of the table that it has the many relationship from becomes the foreign key here, right? Okay. Let's connect this correctly. All right. So I think that's pretty much what the relationships mapping look like, guys. Let me actually zoom this out a bit for you guys to get a better idea of how it looks. So this is how your database is now going to look like. All of these are your entities. Look at all this. These are your entities: customer, biometric, account, loan, transactions, branch IDs. These are all the different attributes. Just remember that this created at is very different from the created at here, okay? Because this was when the account was created at, and this was when the loan was created at. These can be two different dates altogether, okay? But what is going to be similar in nature are all these keys, okay, where the PK, FKs are mentioned. They are usually going to be pretty much more or less the same. So this account ID is going to be the same as this account ID. This transaction ID is going to be the same as, this customer ID is going to be the same as this customer ID. So anyone that basically has a FK or a PK associated with it is usually going to be the same as the other table that it's related to, because we are mapping the relationships, right? So similarly, what I'm going to do here is I'm going to put in these cardinalities here, okay? So it's easier for you guys to understand. Okay. And a minimum here and a maximum here. Okay. Now, I think this should be clear to you guys, a little bit more clear to you guys. I hope this helped some of you. We'll be covering more practical examples in class. Thank you so much.